So let's continue. As I mentioned, linear space creates a range that numbers are linearly spaced, and you provide the number of elements that you want to have between two numbers. Okay, we talked about ones and zeros, we talked about rand and the identity matrix. You can concatenate different matrices together. So here C is a 2 by 2 matrix. D is also a 2 by 2 matrix. What is E? It's 1 by 4. It goes from 5 to 8. And so if you concatenate them together, you put C and D beside each other. This is C, this is D. And then in the next row, you would have E, that's E, between 5 to 8. And finally, the last row numbers -2 all the way to 1. So it goes from -2, -1, 0, and 1. If you remember, the step by default is 1 if you don't provide the step with the colon operator. You can also have the transpose of a matrix. So for example, CLC, let's say we have M. If I say M transpose, what is it going to be looking like? If the M is 2 by 3, M transpose is going to be 3 by 2. Every row of M every column becomes columns of M prime. Or if, let's say we have, do we have identity? Do we have the square matrix? Oh, this is identity. Let's just like create a square matrix 4, 5, 6, 7. You can also, oops, I forgot the square bracket. You can create inverse of S using the inverse function. So this is going to be inverse of S, right? It's like 1 over AD minus BC times transpose of S. So that's basically what we have. And we talked about matrix operation and element-wise operation, right? So like you guys remember this. This is power. In MATLAB, power is used with this symbol, right? And you can raise a matrix to power of something. So what does this mean? Let's say like the same matrix that I have that I created. What does it mean if I say S? What is the difference between this one and this one? Why do I get different numbers? Well, S raised to power 2 means that I want to multiply S by itself using matrix multiplication. Here it means that I want to raise every element to power 2. So that's why we get different answers. So here you're multiplying S by itself using matrix multiplication. So basically 4 and 5 multiplied by 4 and 6 would be 16 plus 30. That's what we have here, 46 in the first element. While element-wise operation becomes 16, 25, 36, and 49, as you see here. I already talked about this. You can also like add or subtract. For adding and subtracting, element-wise operation do not exist because it doesn't have any difference between the matrix arithmetic and element-wise arithmetic in this case. You can only add or subtract matrices if they have the same size, and it basically means that you want to subtract or add them element-wise. But for multiplication, division, and power, we would have two different cases. We would have matrix operation or element-wise operation. Okay, most students who first start working with MATLAB, they would have hard time remembering that they have to put the dot for element-wise operation. Okay, we talked about this. We talked about transpose. Okay. Deconstructing the matrix. Basically, I have, let's say I have a matrix S, CLC, S. What if I want to access the elements in row 1 and column 2? This is how you do it in MATLAB, right? Using round brackets, and you specify first the row and then the column. Let me make a bigger matrix. Okay, A. Let's say A is a, well, it's not a big matrix. Let's say I. What is I? Well, that's the identity matrix. Let me make a bigger matrix. E is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 3, 5, 6, 6, 7, 8, 9, and 5, 4, 3, 2, for example. This is the matrix that I have. It's a 5 by 4 matrix. Okay. What if I want to have E of 2 and 3? So what should be the answer here? What should MATLAB give us? What number? Should give us 7, right? Because we want to access the number in the second row and third column. Oops. Oh, because I printed, sorry, I printed 3. So E of 2 and 3 is going to be 7, right? What if I do it like this? E2 colon. It means that I want to have every number on row 2. So it would give me row 2. What's going to happen if I do it the other way? Column 2. It would basically give me a vector matrix, a column vector that has all the elements on column 2 of E. Okay, so you can use the colon operator for this purpose as well. What if I put colon for both row and column? Oops, sorry. Okay, it would basically give me the whole E. Okay, so that's basically one case of use of colon operator. In addition to creating a range, here you would basically have, so actually let's look at this one. What does this mean? If you have a 10 by 10 matrix, what does this do? It means that I want to grab all the rows from row 1 to 10, but only the third column of A. What should be the size of this matrix? It has 10 rows and only one column, which is the third column of matrix A. How about this one? It would have whatever number of rows we have for A and the first column. What if we do it like this? What if we just like have one column? So let me actually go to MATLAB and do this, E of just one column. So in that case, MATLAB converts E to just a column vector. So that would go from first column 15965, 15965, then 26374, then 37583, then 48692. So it basically converts a matrix into a column vector by going through first column, second column, third column, and fourth column. MATLAB goes through columns first. It doesn't go through rows. It goes through columns. Okay, so this is something that you should remember. The end index. Let's say I want to do this. E of 3 to end, comma 2. What does this do? it basically grabs all the rows starting from row 3 until the end of the rows and grabs only the second column of E. So here it would go from, let me just type E as well. So here you see that it starts from row 3, which is here. It goes all the way down towards the end, but only grabs the information from column 2. So the index end can be used to basically, like if you don't want to specify, like here, like it would have been the same if I say 3 to 5. But if I don't know how many elements I have, how many rows I have, how many columns I have, it's MATLAB provides the end to work with that. One other thing that I should mention here is that the indexing in MATLAB starts from 1. It's different from C++ that the indexes starts from 0. So if I, for example, if I just do this E1 to 3, comma 4, it should give me rows 1 to 3, but only column 4, which is 486. As I mentioned, you can go with a negative step. So it means that here, if A is a row vector, it means that you want to display A from the last element with the steps of -1 going all the way to the first index element of A. So you should just like go backward. You should display A backward. So if you want to reverse an array or reverse a vector, you can use AND very easily to do so. So I talked about indexing in MATLAB. This is another function from MATLAB, so I try to use many different functions here. A magic square matrix is it's basically a matrix that would have all the numbers from 1 to 4 squared, which is 16. And the way they are put here, if you add all the rows and all the columns, they would have the same number. So like for example here, 16 plus 4, 20, 25, 34. If I add this row, it should also be 34. I hope it is. 16, 18, 21, 34. All the rows should be 34. This is 16, 26, 34, and so on. Okay, even the diagonals are going to be 34. 7 plus 11, 18 plus 16, 34. So this is just like a function that I use for example. And if I say 4 and 2, it would grab the element in row 4 and column 2, which is going to be 14. And we talked about this. So here it means that I want to have only the rows 1 and 2 and all the columns of A. Here it means that I want to make all the rows from row 1 to 3 of A and column 3 to 4 of A equal to 0. Right? So you see that like this part from row 1 to row 3 and column 3 and column 4 are made 0. Okay. The same thing happening here. It means that I want to remove elements from this array, from this matrix. So it means that all the rows from row 2 to row 4 with the steps of 2. So it means that only row 2 and row 4 and all the columns. So it means like this row and this row, I want them to be removed from A. So if I remove them from A would be only the first row and the third row. Sorry, this one. Okay, so these are like some matrix manipulations that you can do using the indexing in MATLAB. What happens if we only specify one number instead of both row and column index? So for example, here, if A is this one, if I say A4, as I mentioned earlier, MATLAB goes through indices first. So if you only specify A4, it would just like say this is first one, second one, third one. This is going to be fourth one. Okay. So it should give me 4. In this case, where A is 16, 19, 2, and 7, this is 1, 2, 3, and 4, and it will give me 7. Okay, so this is for this example. So this is called linear indexing. If you just like use one number as an index to go through a matrix, it would go through the columns first. So it would just like basically go through here, then the last column. We're going to talk about different operations that you can do through a matrix: norm, max, and mean. Let's talk about norm later. In the linear algebra section, we talk about norm. But here, like if you want to find the maximum or a minimum of a matrix, you can use the max function. So here, if I just go here and I say maximum of E, it would give me basically the maximum numbers in each column of E. So in the first column, 9 is the maximum. In the second column, 7 is the maximum, and so on. If I say max of E, it would give me the absolute maximum of E. The same thing for minimum. The same thing for sum. If I say sum of E, can you guess what happens? What's the answer? Let me show you the E first. And if I say sum of E, would basically add up each column. So it would give me the summation of the first column, which is 26, summation of this column, which is 22, and so on. Again, if I want to find the absolute sum, it's going to be sum of E. It's going to give me the summation of all the elements inside E. We have backslash that, again, we're going to see this in the linear algebra section. The same thing for QR decomposition or single value decomposition or eigenvalues. We're going to see them later. But this one, if you have A backslash B, it basically solves this linear equation. If you have, let's say, an n by m matrix A and an m by 1 vector x and an m by n and n by 1 vector x and an m by 1 vector b, then the vector of unknowns can be found using A backslash B. The reshape is basically one function that can change the format, the number of rows and number of columns of a matrix. Let's say if you have a matrix which is 1 row, 10 columns, and I say that I want to reshape this matrix and have another matrix called B. So this is not changing A, but the reshaped version of A is going to be placed inside B. It means that I want A, the same numbers that we have A, but only with 5 rows and 2 columns. Okay, so it puts everything that is inside A through B with 5 rows and 2 columns. So you see that like A was 1 to 10, now becomes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, it goes through the columns first and it goes through the rows second. We have another data type, which is a string in MATLAB. So we also can display a number or display a matrix using display function. There are many of these sort of functions. Num to str means number to a string. Okay, so if age is 12, let me copy this one and place this in, actually let me num to string, let's just like put 65 or 66. Okay, it basically creates this one as a string version of this number. So this one is basically a string version of this number. It cannot be added or subtracted. It's not a number anymore. It's just a text, but that text contains number. The same thing applies to str to num. So for example, if I have str to num 23, it makes it a number. We'll see the application of this later. This can be very helpful when you're trying to read, for example, a text file, right? And whatever you read, it's going to be in the string format, but then you want to convert it back to number, you can use this function to do it. Okay. Menu, you can create a menu like this, and we're going to talk about how to create menus and apps later, but this is like a simple menu creation using MATLAB. You can display text or strings using sprintf or fprintf in MATLAB. And we have, similar to C, we have placeholders. So D is a placeholder for double or any number. So it means like the array is something that comes after the comma. This is going to print the array is 2x, and the second placeholder means the second number after the comma, 3. So this is going to print the array is 2 by 3 dot. Here it's going to print, what is it going to print? Actually, you guys tell me. Round, basically rounds a number. Pi is number 3.141592 whatever. And if I do this, it's just going to print 3. Why is it character? Because this is a string. This is sprintf. The same thing with fprintf. They're not exactly the same, but we're not going to get into details of it. So some placeholders, percentage %d or mod d for integer, mod f for float, mod e for scientific notation or exponential notation, and so on. You can, like similar to C++ that you had C in MATLAB, you can say input and get a number from the user. So the way that works is basically using this format. If I just type this here, copy, and I'm just going to go to MATLAB and I say x equal to. So it just like prints the same message that I have here. And if I say, for example, 3, my x becomes equal to 3. You can also display any string using the prompt function. You can just this is the name of a variable. So this variable is a string variable. I'm placing this string inside this variable, right? And when I say x equal to input prompt, it's just gonna ask me this question, and it's going to wait for me to enter a number that would be placed inside x. Pause, it would pause for I think 2 milliseconds or 2 seconds, I'm not sure. Let's just like help pause. 5 seconds. So it would just like pauses for 5 seconds. So you can use these to get some input. So input is the opposite of display. We have relationship operators, same as C++, to compare if two numbers are equal, bigger, smaller. You can also have, this is like the logical OR and the logical AND, which we're going to talk about them a little bit later. And we're going to talk about if, else, and for loops also later. But like we have the same if and for that we have in C++, the formatting is a little bit different though. Not a little bit, it's totally different actually. So let's just like go through the logical operators again. Greater than equal. So if I add an equal here, it would be greater than equal. Less than or less than equal, is equal to, is not equal to. This is logical not, this is logical and this is logical or. Okay. And again, we talk about the difference between two ands and one and a little bit later. Okay. But I just wanted to show you that there are two logical ands and logical ors, so that you can use it to compare things. So for example, here A is this matrix or this vector. Here it says B is equal to A less than equal 5. This is something I can't do in C++, but MATLAB lets me do that. So what does that mean? It means that every element of A that's less than equal to 5 is true. This becomes true, right? A logical operator returns either true or false, right? So this is true, false, true, 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 false. Okay, the same thing for this one. B and C ANDed together. So 1 and 1, true. 1 and 0, false. 1 and 1, true. 1 and 1, true. 1 and 1, true. 1 and 0, false. 1 and 0, false. Okay. We also have something called logical indexing. So here it says A of D. What is D? D itself is a matrix. So it means that I only want to have elements of A that are 1 equal to 1 in D. So it means that I want to have this element, this element, this element, and this element, and this element. So it would give me 1, 4, 5, 2. Logical indexing. It would skip 8, -2, and 9. Okay. And that's basically what logical indexing is. So this is, I explained this, but these are some examples that you can go through and figure out what should be the answer for each of these if I run them in MATLAB. So we come to scripts. I think it's a good place to stop, and we continue later.